So in yesterday's video, I said you need to learn two things, recursion and time complexity. Today we're going to be going over recursion. You're going to need it for the future algorithm videos that we'll be going over. We're going to be using it in a lot of situations over loops. In programming, we have something called loops, and usually it's a for loop or a while loop. There's a couple different types, but the whole point is that you have a block of code and that piece of code gets ran X number of times. This could be something as simple as printing the word hello 10 times. With recursion, it's the same thing, you get the same output, it's just being done differently. So you can make a recursive function that will put out the word hello 10 times. But the difference between a loop and recursion is that a loop is inside a function and it's a piece of it, while recursion, the whole function calls on itself. The whole function really becomes the loop itself. There's not much behind it, so let's jump straight into the code so we can understand what's going on. For this video, I chose Python since it's used a lot with machine learning and algorithms. I could have done JavaScript or C# or something else, but it doesn't really matter. Python is very easy to understand. And if you don't understand, just Google whatever you don't understand from the syntax, but don't let that deter you from the important part, which is understanding what is going on with recursion. Also, these are some examples I just thought about on the spot. They're not perfect. There's a lot better examples, but they would have been more complex, and I don't want to focus on the complexity of the code or the actual problem we're solving. I just want to focus on what is recursion. Okay, so here's our function. We can see it's a function called loop example. It takes in a word and it takes in a count, and then it goes and prints that word whatever times the count. It uses a loop, so you can see 4x in range, and then there's a number that goes in saying how many times you should run that loop, and inside you have the command where you print the word, and when it's done, I have it print the word done. This is what it looks like when you actually run the function. So it prints out the word hello 6 times and then prints out the word done when it's finished. Now here is the recursive function. When making it, you need to follow a couple of rules. You need to have two things inside a recursive function: the base case and the recursive case. The recursive case is what's going to be looping. So if your base case, which is the perfect scenario, the time where you exit the function, if you're not there yet, you go into the recursive case, and that's what should be looped. So in our case, on line 6 and 7, we print out the word, which is part of the loop, and then we go and return the function that we're inside of right now with everything the same except we -1 on the count. So when you run a function twice, let's say, the information from the first one isn't sent over to the second one. Once you run a function and you exit and you call it another time, all that information inside of it is cleared and reset. So we have to send our counter to the function again when it runs the next time. Then on line 3 and 4, you can see our base case where we say if count is 0, so if after the recursive case runs whatever amount of times and it removes 1 every single loop, if it gets to 0, then we're going to print done, and that's it. We're going to exit the function. Here's what it looks like when you run it. Same exact thing. We print it 6 times, then we print the word done, and we exit the program. I'm sure some of you are a little confused still on what's going on. I definitely recommend going to Code Wars or LeetCode or whatever and finding some recursive questions, and even if you don't know how to solve it, maybe just skip to the solution, see how it's done, and try and break down the problem. The point of recursion is to make code a lot cleaner when you're working with algorithms. You want the function to run on itself instead of having to put multiple loops inside and it being a whole mess. You guys are going to see how powerful recursion is when we get into breadth first search and depth first search. Tomorrow we're going over time complexity. It's supposed to be a really quick video. I just want to explain to you guys what time complexity is, how to calculate time complexity, and why time complexity. Why is it important? Why do we need to know how much time it takes to run this code and how much time it takes to run this code, and why is it better to use this one versus the... We're going to go over it all tomorrow. If any of my videos brought you value and you enjoyed this one, it goes a really long way to like the video and subscribe to my channel to help me get back into the YouTube algorithm and maybe even hit it a little bit so my videos can get up in views and I can monetize my channel. Thank you so much for watching, everyone, and I'll see you guys in tomorrow's video.
Goodbye.